In the immense expanse of the cosmos, with trillions of stars out there, it's easy to feel small. But that smallness comes with a huge question. Are we the only ones looking up at the lights? For basically all of human history, we've stared at the stars and wondered, is anybody out there? Well, now we're done just wondering, we're actively hunting for an answer. From the frozen oceans of moons right here in our solar system, to the air of planets light years away, the greatest search in human history is on. This is the story of that hunt, and the clues we're finding are more exciting than ever. To get why this hunt is so thrilling, you first have to appreciate the central mystery. The universe is unnervingly quiet. This is the heart of what's called the Fermi Paradox. In a galaxy as old and massive as ours, with billions of Earth-like planets, you'd think life would have had countless chances to pop up and spread out. Statistically, the sky should be buzzing with signals from other civilizations, but when we listen, there's nothing, just silence. Is life just that rare? Does every advanced civilization hit some kind of great filter that snuffs them out? Or are we just not listening the right way? This quiet is the mystery that fuels the entire investigation, pushing us to invent new tools and methods to find what might be hiding in plain sight. We've become cosmic detectives, and the case is wide open. Our investigation starts close to home. Before we go looking for intelligent aliens in distant star systems, we're looking for any life, even a single cell right here in our own solar system. The first place we're looking, of course, is Mars. We know the red planet used to be a warmer, wetter world, a place with rivers, lakes, and maybe all the ingredients for life. NASA's Perseverance rover is our detective on the ground, and is not just looking for life now, it's drilling into ancient lakebeds to find evidence of life from billions of years ago. It's already found a variety of organic molecules, which are the chemical building blocks of life. This isn't proof of Martians, but it's a huge clue that we're digging in the right spot. Those rock samples are being sealed in tubes, waiting for a future mission to bring them home to our labs, where we can finally check them for the fingerprints of Martian life. But Mars isn't our only target. Further out, around the gas giants, we have the ocean moons. Jupiter's moon Europa and Saturn's Enceladus are covered in ice, but underneath we're almost certain there are huge global oceans of liquid salt water. And where there's water, there's a chance for life. NASA's Europa Clipper mission, which launched in October 2024, is currently on its way to Jupiter. When it arrives in 2030, it'll perform dozens of flybys, using ice-penetrating radar to basically give the moon an ultrasound, mapping the ocean below and even looking for plumes of water vapor it could fly through and sample. Finding life in one of these dark, cold oceans would change everything. It would prove that the spark of life isn't a one-time fluke here on Earth. While one team of detectives digs in the dirt, another is listening for a whisper from across the void. This is the search for extraterrestrial intelligence, or SETI. For more than 60 years, we've aimed massive radio telescopes at the sky, listening for a signal that doesn't sound natural. We're looking for a technosignature, a sign of technology. Think about it. We've been leaking radio and TV signals into space for a century. An advanced civilization nearby could probably pick those up. So we're listening for theirs. Of course, it's like trying to hear one specific conversation in a packed stadium. To help, scientists now use AI to comb through mountains of telescope data, flagging anything that looks weird and deserves a second look. But what if aliens don't use radio? The search is getting broader. With incredible tools like the James Webb Space Telescope, JWST, we can now analyze the air of planets light years away. We could potentially spot an industrial civilization by the pollution in its atmosphere, like high levels of certain gases. Some scientists are even thinking bigger, searching for things like the heat from a planet covered in city lights, or even giant alien megastructures. We haven't heard that whisper yet, but our hearing is getting better every day. This is one of the most exciting investigations in science, and we're uncovering new clues all the time. If you think this hunt is as fascinating as we do, subscribe and join our community of cosmic detectives. Your support helps us keep asking these huge questions. The third front of this investigation has exploded in the last couple of decades: the search for exoplanets. Before the 1990s, we only knew of the planets in our solar system. Today, thanks to telescopes like Kepler and now the JWST, we've confirmed the existence of nearly 6,000 planets orbiting other stars. And we've found a zoo of different worlds. Hot Jupiters that orbit their stars in just a few days. rocky super-Earths, and even mini-Neptunes. The main goal is to find planets in the habitable zone, that sweet spot around a star where it's not too hot and not too cold for liquid water to exist on the surface. But finding a planet in the right spot isn't enough. We need to look for biosignatures, the chemical signs of life. This is where the James Webb Space Telescope is a total game changer. By analysing the starlight that filters through an exoplanet's atmosphere, JWST can sniff out its chemical makeup, looking for gases like oxygen and methane. Finding the right mix could be a huge sign of life. Recently, JWST has been studying a very interesting exoplanet called K2-18b, about 124 light-years away. Observations have detected methane and carbon dioxide, and maybe even a hint of a molecule called dimethyl sulfide, or DMS. Here on Earth, DMS is overwhelmingly produced by life, especially plankton in the oceans. Now, this isn't definitive proof. The signal is faint and needs more study, but it's exactly the kind of clue we've been hoping for. It shows we can finally stop just counting planets and start actually sniffing their air for signs of life. So, where does this leave us? We're on the edge of a massive discovery. We have rovers digging for microbes on Mars, a probe on its way to explore an alien ocean, and the most powerful telescope ever built tasting the air of distant worlds. We haven't found the smoking gun yet. We haven't proven we're not alone. But for the first time, the answer feels like it's within our grasp. The discovery of any life, whether it's a fossil on Mars or a signal from a distant star, would be one of the most profound moments in human history. It would rewrite our science, our philosophy, and our entire understanding of our place in the universe. But what if, after all this, we find nothing? What if the silence just continues? In its own way, that would be just as profound. It would mean this beautiful, fragile, and noisy little world of ours might be the only spark of life in an endless cosmic dark. And that would leave us with a pretty heavy responsibility. Either way, we have to know. The hunt is on, the stakes have never been higher, and the next clue could change everything. What do you think we'll find? Let us know in the comments.